Hello everyone and welcome to part 2 of this week's lecture. In this lecture we will look at what are different types of chemical products and how we can classify these chemicals into different classes. We will also look at how we can decide actually which chemical belongs to which class. And in the second part we will also look at what is the nature of a chemical process design, what is the synthesis of a chemical process, and actually what are different steps to it. And finally, we will look at what are different types of flow sheets that we can prepare to describe a chemical plant. So this unit considers the overall flow sheet, including reactions, separations, recycle, and heat recovery, and its evaluation. The unit draws on a wide range of knowledge that you have accumulated so far in your degree, and also on the knowledge that you are going to get in this semester. The good news is that this unit helps to connect the knowledge from many different courses that you have already taken. Okay, you have taken several courses on heat exchanger design or heat transfer, reaction engineering, chemical or mass transfer. And there is also courses on equipment design and process equipment design, for example, in the next semester that you will take. But this course is different from those because it gives an overall view of all these principles from developing a process or from the viewpoint of a potential chemical project. Um, and these chemical projects, they play a special role in the sustainable development of our society. Because in our daily life, we use chemicals in various forms, such as pharmaceuticals, textiles, soaps, detergents, fertilizers, plastics, and without chemicals, life is very difficult to follow. A chemical plant can be identified as a facility for physiochemical or biochemical transformation of raw material into value-added products for with various resources such as man-powered energy, water, space, or land and money. Okay, so the chemical process or chemical plant is judicious combinations of various unit operations and unit processes. Like for example, in petroleum refinery, crude oil is separated into various fractions such as LPG, naphtha, petrol, kerosene, diesel, and a series of distillation columns are used for these separations. And you have studied distillation as a unit operation in mass transfer course or in separations. When considering the design of processes for manufacture of chemical products, the market into which they are being sold fundamentally influences the objectives and priorities in the design. Okay, so in simple sense that in order to understand design of a chemical process, we need to understand what kind of chemicals we are going to manufacture. Okay, so now let's have a look at different classes of chemicals. So there are actually three broad classes of chemicals. First is the commodity or bulk chemicals. Second one is the fine chemicals, and the third one is the specialty chemicals or functional chemicals. Commodity chemicals are produced in normally in large volumes, and they are sold on the basis of composition or purity, and the composition and purity is the factor that determines their price. Okay, and the example of these chemicals are sulfuric acid, nitric acid, nitrogen, oxygen, and chlorine, and many other such chemicals. For fine chemicals, they are produced in relatively smaller volumes, but like commodity chemicals, they are sold on the basis of composition and purity. And again, these are the factors that determines their price. Some examples of fine chemicals are, for example, chloropropylene oxide that is used in epoxy resins, or dimethyl formide, which is used as solvent in reaction medium and intermediate pharmaceutical manufacture. Then we have butyric acid, which is used in beverages and in flavoring and fragrances. Okay. And finally, we have the third class, that is specialty chemicals or functional chemicals, and they are manufactured for a particular or specific application, and it is the function of these chemicals which determine their price rather than the chemical composition. For example, perfumes, flavoring, or pharmaceutical products. Even a simple chemical such as a mosquito repellent that we use at our home, or domestic cleaners. So all these chemicals are rarely bought on their chemical composition. Okay, so but we mainly look at their function, like how effectively they clean or how effectively they repel mosquitoes. Okay. So it is the function of these chemicals that determines their price rather than the chemical composition. Now let's look at these chemicals in a bit more detail and see that what are the individual features of these chemicals. So there are four main factors that help us decide how we can classify a particular chemical product into a specific class of chemicals. And these factors are composition versus function, scale of production, profit margins, and if the chemical is considered as differentiated or undifferentiated. So let's have a look at what it means, what these factors are, and how we can actually use them to classify a chemical. Okay, so let's look at that. So first one, we have commodity or bulk chemicals. Okay, so as the name suggests that these are bulk chemicals, it means that they are produced in large quantities. So for the scale of production of these chemicals, they are normally produced in quantities above 1,000 ton per year. Then we have composition versus function. For these chemicals, as I defined before, that composition and the purity is the main factor that dictates their price. Okay, so the function of these chemicals are not that important. And these chemicals, because they are normally produced in very large quantities, and normally the cost of production of these chemicals per unit is quite low compared to specialty and fine chemicals. And also these chemicals have low added value. So what it means that they have a small margin of profit. Okay, so added value is the difference between selling price and the cost of raw materials. And in simple sense, it means that per unit, how much profit you are making to produce that specific chemical. So these chemicals, because they are commodity chemicals, there is nothing special in terms of their function. So you have to produce them in large quantity to get the profit out of them, because per unit product you have very small margin. Okay, and because the commodity chemicals tend to be purchased on the basis of their chemical composition alone, they are considered undifferentiated. And what it means that there is no difference between the product between two different manufacturers other than the price and delivery. Okay. For example, there is nothing to choose from between 99.9% benzene made by one manufacturer and that made by another manufacturer other than the price and the delivery issues. Now let's have a look at some of the features of fine chemicals. So fine chemicals are normally produced in relatively smaller volumes, less than 1,000 ton per year. And that is the only main difference between fine chemicals and commodity chemicals. Okay, for the rest of the features, they are the same. Just like commodity chemicals, fine chemicals are also purchased in the market based on their composition or purity, and that is what dictates their price. One other difference is that fine chemicals are normally high added value. What it means that they have higher profit margins compared to commodity chemicals. For commodity chemicals, we have low added value or low profit per unit product. But for the case of fine chemicals, we have higher profit margin per unit of the product. Okay. For the case of fine chemicals, because they are produced in smaller quantities, we also need a relatively lower capital cost. Okay, so it means that the plant size is going to be small compared to a commodity chemical plant. But despite having a small plant or small capital cost, we have high capital cost per unit of the product. Okay, because we are producing much less products compared to what we prepare for a bulk chemical plant or a commodity product. These chemicals are also considered undifferentiated products. It means that a product would be very similar between two different manufacturers. Okay, so there is no big difference between the product between different manufacturers. Okay, and finally we have the specialty chemicals. So specialty chemicals are produced even in smaller quantities compared to bulk chemicals and fine chemicals, normally in the range of 500 tons per year. Okay, and their main criteria is that they are purchased based on their function, not on their composition. Okay, as I explained, that if you have, for example, a cleaner product, so you are mostly interested in the level of cleaning that product is doing, not so much on the composition of that product. Okay, and specialty chemicals are very high added value. It means they have very high profit margins compared to commodity chemicals and fine chemicals. And again, because these chemicals are produced in much smaller quantities, so the plant sizes are going to be small, and because of that they have much less capital cost requirement. But again, because we are producing much smaller quantities, the capital cost per unit of the product is still going to be high compared to commodity chemicals. So when a specialty product is first developed, it is normally protected by patent so that you can stop the exploitation of that product by other manufacturers. And normally a patent lasts for 20 years. It means that after 20 years, the other manufacturers can use the recipe to produce the same product. But if competitors cannot wait until the patent expires, then they have to develop alternative products to bring to the market. Another way to protect a competitive edge for a new product is to protect it by secrecy. For example, the formula for Coca-Cola has been kept a secret for over 100 years. Okay, but obviously you have to protect it to avoid any competitive products into the market. Okay, and that is why most of the industry, they are very secretive about their manufacturing processes. Okay, so you cannot get any detail from Dow or from other bigger manufacturers about what kind of process conditions they are using. So these are all kept very secretive. Okay, and the main reason is to keep a competitive edge in the market. So specialty chemicals are normally considered as differentiated because they are mostly purchased on the basis of their effect or function. Okay, so for example, a competitive pharmaceutical products are differentiated according to the efficacy of the product rather than the chemical composition. Similarly, an adhesive is purchased on the basis of its ability to stick things together rather than its chemical composition, and so on. Now we can classify different chemicals into different classes based on if they are differentiated or undifferentiated. However, undifferentiated and differentiated should be thought as relative terms rather than absolute terms for chemical products. In practice, chemicals do not tend to be completely undifferentiated or completely differentiated. Commodity or fine chemical products might have impurity specifications as well as purity specifications. And the traces of impurities can, in some cases, give some differentiation between different manufacturers of commodity and fine chemicals. For example, 99.9% acrylic acid might be considered to be an undifferentiated product. However, traces of impurities at concentrations of few ppm can interfere with some of the reactions in which it is used and can have important implications for some of its uses. Such impurities might differ between different manufacturing processes. Okay, so in this case, acrylic acid should be considered as undifferentiated, but if we look at it from the perspective of the small quantities of traces it has, or the type of traces it has, we can actually differentiate between different manufacturers. Similarly, not all specialty products are differentiated. For example, pharmaceutical products like aspirin are differentiated. Different manufacturers can produce aspirin, and there is nothing to choose between these products other than the price and differentiated created through marketing of this product. This slide illustrates different product life cycles, and chemicals can have different product life cycles depending on the market conditions, patent protection, and competition. And the general trend is that when a new product is introduced into the market, in the beginning the sales grow slowly and then more rapidly once the market is established. Okay, and if you have a patent protection, then competitors will not be able to exploit the same product commercially until the patent is expired. Okay, so all these factors, market conditions, patent protection, and competition with other manufacturers actually influence your product life. So here you have 4 different products with 4 different life cycles. So product A, as you can see, has a very short product life, um, and it might be because it was not able to compete with the other products into the market, and that's why it was taken out of the market relatively soon. Then you have product B that relatively did better. So initially you had a slow growth, and finally, again, after a certain time, your growth became more stable. And finally, when the patent expired, it totally dropped because the other manufacturers could manufacture the same product, and as such, the share of the market was divided among different manufacturers. Now we have product C, and product C is actually still better than product B, and it shows a good high volume of sales in its life cycle, and then there is a slight decrease, and then you can actually reformulate this product to extend its life cycle, or actually you can start a new life cycle after reformulation. And finally, we have product D that is showing a life cycle that is typical of a commodity type chemical product, where you have an significant increase in the initial part of its life of the product, and then after a certain time it enters into a mature period of slow growth, and in some cases decline, but most of the time it continues to increase slowly. Okay, and this is because commodity chemicals tend to have a diverse range of uses. Even though competition with other manufacturers take away some of the end uses, new end uses are introduced, leading to extended life of the product. So what is important to remember in this part of the lecture, it is that when you are designing a chemical process, it is important to understand the features of your chemical product that you want to manufacture, because it is going to influence the objectives and the priorities of your design. Okay, because if you are designing a commodity chemical, you are going to have different process requirements and objectives. You will have much larger system to design compared to when you are designing a specialty or a fine chemical product based plant. Then you have much smaller plant, but then you have different requirements of the process. Okay, so the decisions and objectives that you set, decisions that you make for your process, and the objectives that you set in your design are influenced by the type and the properties of your chemical product.